For most of human history, the stars appeared permanent. They looked like distant points of light, separated from Earth by unimaginable distances and seemingly untouched by our existence. But occasionally, something crosses that familiar sky and reminds us that our solar system is not an isolated island. An object can arrive from another stellar neighborhood, pass through the gravitational domain of the Sun, and then disappear back into the darkness between the stars. That is what makes an interstellar visitor so extraordinary. Unlike ordinary comets, which spend their lives orbiting the Sun, an interstellar object follows a path that reveals a different origin. Its trajectory can tell astronomers that it was not born here. It came from somewhere else. The first confirmed object of this kind, 1I, Oumuamua, was discovered in 2017. 2 years later, astronomers identified 2I, Borisov, an unmistakably comet-like visitor. Now, the discovery of another interstellar object has created an entirely new opportunity. Instead of simply watching a faint point move across a telescope image, astronomers can study its light, its activity, its composition, and its behavior in much greater detail. The James Webb Space Telescope is particularly valuable because it observes the universe in infrared wavelengths. This allows scientists to investigate extremely faint material and study gases and dust surrounding distant objects. What makes an interstellar object fascinating is not necessarily that it looks completely alien. In fact, the opposite may be more important. The same fundamental elements found throughout our solar system can also appear in material formed around other stars. Carbon compounds, water-related molecules, dust, and other chemical ingredients can survive inside icy bodies for enormous periods of time. That means an interstellar visitor can become a natural sample of another planetary system. We cannot simply travel to a distant star and collect material from its planets. But occasionally, another star system may send some of its debris toward us. Imagine a fragment being expelled during the chaotic formation of a planetary system. It could spend millions or even billions of years drifting through interstellar space before eventually passing close enough to another star to be detected. Its journey would be almost impossible to reconstruct completely. Yet its chemistry could preserve clues about where it came from. Its surface may contain evidence of radiation exposure. Its dust could reveal the environment in which it formed. Its gases could provide information about the temperature and chemistry of its original planetary nursery. And its orbit provides another critical clue. If an object's trajectory is strongly hyperbolic, it means the Sun does not have enough gravitational influence to permanently capture it. The visitor is simply passing through. The Sun bends its path, but eventually the object continues outward again. That makes these encounters incredibly rare scientific opportunities. For a short period, an object created around another star becomes part of our astronomical neighborhood. Then it leaves. But the information it carries remains. Every measurement gives researchers another piece of evidence about how planets and small bodies form beyond our own solar system. And perhaps the most fascinating question is what these objects tell us about the galaxy itself. If other planetary systems regularly eject rocks and icy bodies into interstellar space, then the space between stars may be filled with countless fragments of planetary history. Most will never be detected. Most will never pass close enough to Earth. But a tiny fraction may cross our path. And when they do, humanity gets something extraordinary. A brief opportunity to study material that was created under a completely different sun. The visitor may be temporary. The scientific knowledge it provides could last. The deeper significance of an interstellar visitor begins when we stop thinking of it as simply a strange comet and start viewing it as evidence of a connected galaxy. Every planetary system is born from clouds of gas and dust. As stars form, the surrounding material begins assembling into planets, moons, asteroids, and comets. The process is violent and chaotic. Collisions are common, gravitational interactions are powerful, and some objects can be thrown completely out of their original systems. Once expelled, those objects become free travelers. They can wander through interstellar space for extraordinary periods of time. During that journey, their surfaces are exposed to cosmic radiation and high-energy particles. Their interiors may remain preserved beneath layers of ice and dust. Then, perhaps after millions or billions of years, one of these travelers encounters another star. That is when its hidden history becomes visible. As an interstellar object approaches the Sun, increasing heat can activate frozen materials near its surface. Gases escape. Dust is released. A faint cloud may form around the nucleus. For astronomers, this activity is extremely valuable. The material leaving the object can reveal its chemical composition. Instead of seeing only a dark point in space, scientists can examine the fingerprints of molecules that were stored inside a body formed somewhere beyond our solar system. And this leads to a remarkable possibility. The ingredients needed to build planets may be widespread throughout the galaxy. Complex organic molecules are not unique to Earth. Carbon-based chemistry has been observed in many astronomical environments, including clouds of gas and dust, comets, and other small bodies. This does not mean that interstellar objects contain life. There is currently no evidence that such visitors are living organisms or artificial spacecraft. But they demonstrate something scientifically important: chemistry can travel. Material produced around one star can eventually move through interstellar space and encounter another. Over immense stretches of time, the galaxy may therefore function as a giant exchange system. Stars are not completely isolated from one another. Their planetary systems can release material. Their gravity can redirect passing objects. And occasionally, those objects can become temporary visitors in another stellar neighborhood. This changes the way we think about planetary formation. Earth formed from material that existed in the early solar system. But some of the raw ingredients involved in planetary formation may have originated in environments influenced by earlier generations of stars. The universe has been recycling matter for billions of years. Stars are born. Stars evolve. Some eventually explode. Their material spreads outward. New stars and planetary systems form from that enriched material. Interstellar objects become another part of that enormous cosmic cycle. And perhaps this is why these discoveries are so powerful. They allow scientists to study the universe not only by looking at distant stars, but by examining objects that physically travel between stellar systems. The visitor itself will eventually disappear. Its distance from the Sun will increase until it becomes too faint for our instruments. Eventually, it will return to the enormous darkness between stars. But its journey will continue. It may pass another star millions of years from now. Perhaps it will encounter another planetary system. Perhaps another civilization, somewhere in the distant future, could detect a similar visitor and ask the same questions we are asking today. Where did it come from? What environment created it? How long has it been traveling? And how many other worlds has it passed? For humanity, the greatest lesson may be surprisingly simple. The universe is not made of isolated islands. Matter moves. Chemistry moves. Planetary debris moves. And occasionally, pieces of distant worlds cross the boundaries of our own. An interstellar visitor is therefore more than a temporary object in the sky. It is evidence of a galaxy in motion. A fragment of another system. A traveler without a destination. And for a brief moment, a piece of the space between stars becomes visible to us. Then it continues onward, carrying its ancient history back into the darkness.